Here is the introduction of AVM application on semiconductor CVD and PVD process. This is the overview of AVM applications on semiconductor CVD and PVD process. The detail will show in the below animations. First, turn sampling inspection into 100% inspection. The general way to perform quality inspection is do sampling inspection in industry. It does reduce the cost of measurement, but will lead to quality uncertainty. Also, user can only get the delayed measurement data after the wafer is completed. Without measurement, we can't get the value of every wafer's measurement items. How can we solve it? AVM can predict the measured items such as thickness of every wafer in real time by the sensor data in production tool. Furthermore, AVM perform constantly self-learning and the prediction model will be adjusted by new in-measurement data automatically, which could ease users' burden of building models. With AVM, user can get quality information of all wafer, even it's unmeasurable, and turn delayed sampling inspection into inspection all in real time. Second, reduce sampling rate. For example, when the sampling rate is 20%, which means in a lot, 25 pieces of wafer, there will be 5 pieces of wafer sent to measure. We can't ensure the quality of the other 20 pieces of wafer in this case. Also, we can't reduce sampling rate due to the concern of quality uncertainty. Assume that it takes 10 minutes to measure a piece of wafer. 5 pieces of wafer will take 15 minutes, which means the process cycle time will increase 15 minutes to waiting measure result. In the same case, with AVM, we can get the quality information of 25 pieces of wafer by the data, which will affect product quality from process tools. AVM system process constantly self-learning and auto-adjust model when there is new in-measurement data, which is the burden of building models. Also, user can reduce sampling rate because now user can ensure the quality of all wafer. In this assumption, each piece of wafer of measurement takes 10 minutes. If we reduce the sampling rate from 20% to 8%, there will only 2 pieces of wafer measured in a lot and only takes 20 minutes. Measure time will decrease from 15 minutes to 20 minutes. In other words, it reduces 60% of cycle time. Third, tool and production abnormal detect. AVM can determine if the equipment and production is abnormal through the data, which will affect product quality from process tools, and index these irregular variations such as GSI and DQIX. Once AVM determined the equipment and production is abnormal, alarm message will be sent, and user can take action according to the alarm information. With AVM, once wafer out of GSI and DQIX spec, alarm message will be sent for user to check tool status in real time. Fourth, run-to-run feedback application. In the usual way, we can only perform process control according to the measurement data through sampling inspection, instead of adjusting recipe by every wafer's condition, which easily lead to extra loss. With traditional process run mode, OS ratio will be high. How can we solve it? With AVM, even though user doesn't measure every wafer, user can still get the quality information such as thickness through data affecting product quality in production tool and process. If user integrate AVM with run-to-run system, AVM can pass the quality information of every wafer to run-to-run for recipe adjusting, which not only decrease the ratio of OS, but enhance CPK. With AVM and have feedback control, OS ratio can be decreased significantly. Fifth, run-to-run feed-forward control application. The usual way of industry is to adjust recipe according to the measurement data from previous process, which means if the measurement data of sampling inspection from previous process didn't show abnormal, user will probably ignore pieces that are actually out of spec and miss the recipe adjustment. This may occur extra loss on production line. With traditional process run mode, OS ratio will be high. How can we solve it? With AVM, the data affecting product quality in tool and process from previous process will generate a predict value and pass to on-site run-to-run. This value can help run-to-run control adjusting recipe based on the condition of each piece of wafer. With AVM and the data from previous process, out-of-spec ratio of on-site process can be decreased significantly.